Now that we're here, let me give you a quick recap of what just happened. Let's walk through the key steps. First, in the constant folder, since this is a steady laminar case, we kept everything very simple. In that folder, we only need one file, transportProperties, and nothing else for the physics setup. In transportProperties, we set new, the kinematic viscosity, so OpenFOAM can use it in this run. And we computed that viscosity from the Reynolds number using our length and speed. We targeted re equals 2200. With the length known, we back-calculated new directly. Once new is set, we move to the system folder, where the mesh and settings live. The most important file there is blockMeshDict, and this is the final version we used in practice. Using it, we generated the mesh around our square cylinder, and this is what you should get. If meshing fails, pay close attention to the point section and these coordinates right here. Type those points exactly into blockMeshDict, so OpenFOAM builds the mesh correctly every time. That will reproduce my setup. Here you can see the complete list of all vertices we defined. Next, we define the blocks, meaning how the domain is divided into structured regions. We chose the blocks, set the cell counts, and then adjusted simple grading to control the local refinement. The goal is that the cells near the square are similar in size to their neighbors for smooth transitions. If you get stuck here, just copy the numbers exactly as you see them in the blocks section below. We had no edges to define. After that, we moved on to the boundary definitions. For the inlet, we used a patch type. For the outlet, also a patch. And here are the face numbers you need to assign. Then we set the faces that make up the obstacle surfaces, and we continued by defining the upper boundary. After that, we defined the bottom boundary too. If you have issues, use the values written here as a reference. Keep this information, because in the next example, we will reuse the exact same mesh. We will reuse it step by step and make the case more complex. Next are the remaining files. You will also need controlDict, FV schemes, and FV solution. I copied them from Cavity today. You can copy those files too and use them here without changes. So that's the full recap of what we built in this chapter. In the next part, we continue from here.